Yeah, now it's being recorded. So today we will see the differences between differences between fungible tokens and non-fungible tokens, and their usability. So that when you are developing a system, if you want to, yes, Damaris.
Yesterday you had said you'll clarify about proof of stake and proof of work prior to
Yeah.
starting today's class.
Okay. Yeah. Yeah. So the reason why proof of stake and the reason why proof of stake is not proof of stake but proof of work is expensive is that because for your transaction to be validated, you pay gas fee, and in recent time that was between 2020 and 2021, that is between December all the way to around March, April there. The gas price, even right now, the gas price is still high. So what happened is that most people who are holding Ethereum, so that Ethereum was dropping, and they kind of dipped the coin. So most of them dipped the coin, and in so dipping, the network had a lot of congestion on different exchanges. And then there were other people, because of the dip, now they were buying cheap at the same time, because they saw people start like dumping the coin or something. So the network had a lot of transaction, and you know that the network processes transaction based on fast come the first node to solve the puzzle. So there are different transactions that are there. And another thing is, apart from congestion, is that proof of work uses a lot of power. Uses a lot of power, so you need to pay miners, or you need to pay miners a push money. You need to pay miners. Apart from the reward, you also need to pay miners, and there are very few miners. There are very few nodes that actually that validate transactions. So yeah. So proof of
Okay, so proof,
yeah.
just go on.
So proof of on the other hand, proof of stake, people just you the reward that is mainly mined by you remember, the miners and the node themselves has to must mine must mine must mine the transaction and verify the transaction, and after mining they are rewarded with five ETH, but at the same time the transaction fee goes to them because of the computation power. But for proof of stake, you only hold your coin. There is no yes, the node will be there, but let me just open the the other PowerPoint.
Okay, so proof of work involves solving the complex mathematical equations.
Yeah, a cryptographic puzzle, But in proof of stake, you only stake your coins. You only stake your coins, like the wallet, the not the wallet, but the software that I showed you. Currently, the Zero blockchain are having a governance proposal. They are having they are calling it the zero GP, the zero GP. I think it's zero gold proposal or something, and people are staking. So you only need to stake for you to for them to change the network or to pass that proposal. Think of it as the way the parliament sit, the way they vote, uh, they have to come. Okay, let me just open the slide because I the lesson it's under Ethereum tokens, consensus mechanism. Yeah, so proof of stake is a common consensus algorithm that evolved as a low cost, low energy consuming alternative to proof of work algorithm. It involves allocation of responsibility in maintaining the public ledger to a participant node in portion to the number of virtual currency tokens held by it. So this other one requires you to solve a cryptographic puzzle. Now, solving that cryptographic puzzle normally involves a lot of computing power, and computing power uh, requires a lot of energy, requires that's why you normally hear that countries that have good power supply, they normally have good they are the countries that normally do the Bitcoin mining, because you have to like have many leagues. But for proof of stake, it's a particular node is given responsibilities, and it is given responsibilities depending with the coin the the depending with the coin it holds. So think of proof of stake and proof of work as this. Uh, in long time ago, for you to be given, like to be paid, or for you to be even paid, you must show that you have worked so that you earn that reward. Yeah. But on the other hand, uh, for proof of stake, you must show how many cows do you own as a farmer, so that when you are voting in your dairy cooperative, you will be given much power because you have a lot of cows in your farm. Now that is proof of stake because you have a lot of cows. But on the other side, if you want to be paid, you must prove that you have worked. You must show, and how you can do that is by signing in your attendance form. If you are working, you have to sign in during morning hours on. Yeah, those are some of the things that miners or people who are doing proof of work has to like verify. They have to show that they have worked and they have solved. Now for you to work, you need a lot of energy. You need a lot of energy in terms of electricity, and also in terms of computing power, your cpu itself. So on proof of stake, you only need to show that I own this amount of coins. So if I vote for this, it's allowed because I'm staking my coin. These are my own coins, you see. These are my own coins, and if I stake these coins, I'm the one who is going to lose this coin. The same thing that also happens with shares. The person who is bringing a lot of investors or a lot of investment in a company is the one who is given the majority shares. Yeah. So that is the difference between proof of work and proof of stake. So proof of work does not require energy. It doesn't require computing power, and it doesn't require electricity because you are just holding coins. Yeah. I hope that is clear. And then there is the if you can be able to, like, if you have interacted with Polkadot and Avalanche and the new blockchains which are using proof of stake, even Zero blockchain, you you can be able to, like, tell the gas fee are less, the transaction cost is less. Yeah, because you don't need a lot of responsibilities have been moved and taken to a particular node that has a lot of coins. That's why Ethereum is trying to move from proof of work to proof of stake. Yeah, and
Uh,
yeah,
when,
yeah.
when you say like a proof of work, it's proof of stake is dependent on maybe the number of tokens
Mhm.
that maybe someone hold.
Yeah, yeah,
Will that not contribute to the other time we talked about 51% attack?
yeah. Now, to counter that 51% attack on proof of work, proof of stake, uh, let me. So to counter the proof of work on uh, to counter proof of stake, that is 51% attack. Uh, So if yesterday we mentioned that if you are holding your coins and you try to attack the network, your coins will be invalidated. They will have no value on your on. They will have no value. You will actually lose your coin. Yeah. So if a hacker would like to, uh, and then again, if a hacker wants to, like, attack your network, a hacker who wants to, a malicious node that wants to, like, sabotage the blockchain or the network, if they try to go and buy the coins, then the coins will have to be sold at a higher price, meaning that you won't be able to, like, change. So imagine this: if you are holding your shares of a company, and then somebody who wants to, like, sabotage the company, definitely you will sell your shares at a higher price. So the same case for proof of stake, because it's your money which is there, and you wouldn't want to gamble with your money. Like, you wouldn't want to invalidate your money. You wouldn't want your money to be invalid. Yeah. Is that uh, okay?
That's fine.
Yes.
It's okay. It's understood.
Yeah, yeah. So yeah, this is how in proof of work, the benefit that it's provide, we mentioned about that it's energy saving, it's a safer network as attacks become more expensive. So for you to, like, do that 51% attack on a system, then you will have to buy the majority of the coins in the system. You have to, like, if you want to now change the entire company, you will have to buy all the shares the shareholders hold, so that you become part of it. And by the time they come to you, you come to them, they will be selling the shares at a higher price. So then that makes the attack expensive. Yeah. So that is on proof of stake and proof of work. Yeah. So we can go on. Is it okay if we go on?
Yeah, it's understood. Thank you.
Okay. Yeah. So then we have when you are creating your token, you need to. These are some of the things that you can consider when creating tokens. So we have and the differences depending with your project. This is how you can. These are the comparison you can take, so that you are able to distinguish. Yeah. So we have fungible tokens and non-fungible tokens. So fungible tokens are the ERC20 tokens, and they are interchangeable. A token can be exchanged to another token of the same type. So if it's a USDT to Litecoin, you can be able to exchange it. If it's an ERC20 token and another one is an ERC20 token, you can be able to interchange. Whereas for non-fungible token, they are not interchangeable. So non-fungible token cannot be replaced with another non-fungible token of the same type. If you read a token to somebody else, you expect the person to return you the same token and not another of the same type. You cannot exchange your birth certificate for another birth certificate of another person. So this one applies for creative arts. So if you lend your birth certificate, you don't expect somebody to give you a different one. Yeah. Fungible tokens are unique. They are uniform. All tokens of the same type are identical in specification. Each token is identical to another. So the ERC20 token follow a particular standard, and they have uniformity. For non-fungible, they are unique. So one is for maybe birth. That one is unique. If you want little unique identity, like your birth certificate is something which is unique. A digital art is unique to the artist who have created. Every art is unique. Every music is unique. So each token is unique and different to other tokens of the same type. So they all will be non-fungible token or NFTs, but they are different. Uh, Tokens or fungible tokens are divisible. So you can divide ERC token into smaller units, and most of the ERC20 token normally use 18 decimal places. It doesn't matter which unit you get as long as the value is the same. In an analogy, with a dollar, it's the same if you get $1 bill or 2.50 or 4 quarters. Then non-fungible tokens are not divisible. They cannot be divisible. The elementary unit is one token and one token only. Then we have the standard, the fungible token follow the ERC20 standard, the well-known standard on the Ethereum blockchain that allows the issuance of tokens like OMG, SNC, TRLets. And then we have ERC 721 standard, which is the standard for all the non-fungible tokens under the Ethereum blockchain that gives the possibility to issue unique and fungible token. Most well-known use cases at the moment are CryptoKitties and other crypto collectibles. So in economics, fungibility is the property of a good or a commodity whose individual unit are essentially interchangeable. So token are fungible when we can substitute any single unit of the token for another without any difference in its value or function. Strict speaking, if a token's historical provenance can be tracked, then so historical provenance can be So historical provenance can be tracked, and then it is not entirely fungible. The ability to track provenance can lead to blacklisting and whitelisting, reducing or eliminating fungibility. So each non-fungible token is associated with a unique identifier, such as a serial number. So if a token represents an asset, it is key to understand who holds the asset and when and what rules up. Yes,
I have a question. You've
yes,
said that the fungible tokens are mostly ERC20 tokens,
yeah,
and then
yeah.
the non-fungible are ERC8 or
Seven, seven,
721.
yeah,
I only see in the Ethereum network we have ERC 800 and something. We have that is I think 1000 and something. What
yeah,
does
yeah.
this mean?
In Ethereum, we have different standards for different smart contracts. So let me show you something. Okay. So in Ethereum, we have different protocols because different projects or different smart contracts require different approach, and then the standard also changes. You see, uh, so in Ethereum, Ethereum developers. So this is the Ethereum for organization developers documentation. And here you can learn more about these protocols or standards and standards. So here are the standards. So we have the Ethereum standards, and we have the Ethereum, this one, Ethereum improvement proposals. So recently we have had the EPIS 1559. That was an improvement proposal that the Ethereum community or organization wanted to upgrade or to approve to be accepted by the community or the developers. So from here you can be able to see these are the two standards, the ERC20 token and the ERC721. Then there are other, there are more other standards that you can use on your smart contract. Like for something like not an NFT, but for something like DeFi, the smart contract will definitely change. It will be different from there will be an ELC. There will be an ELC's ELC. Let's just go to their GitHub repo. Uh, Git. So here at Uniswap, this is the Uniswap core V3 core smart contracts. So if you take a look at the interfaces, we have different smart contracts. So we have different smart contracts that are learning like an entire system, so that they address the same cause. So the reason why they enforce the actual reason why they enforce these two standards for non-fungible and non-fungible and fungible token is because there was a time when everybody was creating their own logic. So when it comes to using them, it becomes hard, it becomes difficult for developers. Because now, if let's say for example we build an ERC20 token that is following a different standard, then we want to integrate it to an ERC20 that has that has a decimal place of eight, that has a decimal place of eight, you int eight, and then another one has a decimal place of 18 values. So when they come to communicate, then the developers will have to create a way so that the other ERC20 token reaches the either the 18 decimal places or the 8 decimal places. Yeah. So that's why they had to create a standard interface whereby this is not the final cause, it's something that has been improved. It's something that has been improved. It's something that has been changing. So if you can take a look at this, the body of this one, ERC20 token, it must have a name, it must have a symbol, and it must have a decimal place. So it can either be uint 8 or uint 18, but most of the ERC20 token follows the 18 decimal places, the 18 decimals, because Ethereum uses 18 decimals, but for Bitcoin uses 8. So that's why the standard had to be created. But for the other ERC 800 and 1000 and others, they are other standards for different tokens. Yeah.
Okay, so we can say if you have an ERC20 token, it's just a token that follows the ERC20 protocol. So let me say like a rules, something like a compliance.
Yeah, it's a compliance. So if you're developing a fungible token, then you have to follow those standards. You have to follow those standards. Yeah. If you are creating an NFT, you have to follow the 721 standard. If you are creating another smart contract, you have to follow another standard. Yeah. But the common standard is the ERC20 and ERC 721. So here you can under the Ethereum organization, you can learn more about it. You can learn more about it. Yeah. So that is on the ERC20, the Ethereum token standard. So we will dive deeper on lesson. I think it's lesson is it 7? Yeah, lesson 7. So not lesson 7, but lesson 6. Lesson 6. So here on lesson 6, we will learn more about how you can be able to create one token and deploy that token on the Ethereum blockchain. Yeah. So I hope you can see my screen. Yeah. Okay. Is there another question?
No.
Okay. So if a token represents an asset, it is key to understand who holds the assets and what rules apply to that underlying assets. That's why we talked about counterparty risk. Is the risk that the other party in a transaction will fail to meet their obligation. Additional counterparty risk, if there are more than two parties involved in a transaction for certificate of deposit, like for that one, for maybe you are creating a system for supply chain, then the parties involved are more than two. So a transaction for certificate of deposit for a precious metal will involve at least three parties: the seller, the buyer, and the custodian of the precious metal, who by necessity becomes party to the fulfillment. When an asset is traded indirectly through the exchange of a token of ownership, there is additional counterparty risk from the custodian of the assets. So, do they have the assets? Those are the main questions that you will ask. Will they recognize or allow the transfer of ownership based on the transfer of a token, such as a certificate, deed, title, or digital token? So these are the explanations of these parts of over here. Uh, mm, yeah, the ones which were here above. So under intrinsicality of tokens determines if the ownership of the associated assets carry any counterparty risk. So intrinsic token represent digital assets that are intrinsic to the blockchain and are governed by consensus rules, just like the tokens themselves. Tokens that represent intrinsic assets do not carry additional counterpart risk. If you hold the keys for a CryptoKitty, there is no other party holding that CryptoKitty for you. So they don't have that risk of counterparty risk. Uh, if you have ever done a transaction on local cryptos, sometimes you wonder, if I send this money, will the other party release the escrow, or will they be able to like fund the escrow? Will they be able to do? Will they be able to do so? So sometimes it even becomes hard to do the transactions. But for intrinsic cryptos, there is no third party, or there is no other party holding anything from you. So the blockchain consensus rule apply, and your ownership, i.e. control of the private keys, is equivalent to ownership of the asset without any intermediary. The same way you hold your coin on your MetaMask wallet or Trust wallet, there is no other party that is controlling your fund. So you are your own bank. You are your own bank, and the company itself, the company itself, or the creators of the token, don't really hold you responsible. If you go there and use that cryptocurrency or that fiat money that you have to buy whatever you want to buy, then nobody will hold you responsible for what you have done, because you or your own bank. If you have your money on your pocket, they are not in the bank. You are your own bank. So if you spend it bad, if you spend it wisely, then the problem will all be yours. You won't go blaming the bank that the bank was the one which misused your funds. So blockchain-based tokens have the ability to convert extrinsic into intrinsic asset and thereby remove counterparty risk. So conversely, many tokens are used to represent extrinsic things like real estate, corporate voting shares, trademarks, and gold bars. The ownership of non-intrinsic asset is governed by law, custom, and policy separate from the consensus rule that govern the token. So token issuance and owners may still depend on real world non-smart contracts assets. But yeah, extrinsic assets carry this is becoming more business and more finance. Extrinsic assets carry additional counterparty risk because they are held by custodians. recorded in external registry, all controlled by law and policies outside the blockchain environment. So there are these assets like the way we have talked about real estates and corporate voting shares. Sometimes they have policies and laws that are outside the blockchain. So these tokens have that ability to convert them into into something variable. Yeah, still depending with the still depending with the policies outside the blockchain environment. So a good example is moving from equity in a corporation, extrinsic value, a value that is of which is outside the blockchain, to an equity or voting token in a DAO or similarly intrinsic value organization. So this becomes now an internal value on the blockchain. If you move your corporation or your organization to blockchain and creating a token that can be used for voting, now representing the corporate voting shares. But the policies governing the token will be made, won't be, somehow they won't be part of the blockchain policy, the blockchain, they won't be in blockchain environment. So if you move your organization to decentralized autonomous organization, now you create an internal and a more greater value, because now your company can have uh, international or boundaryless shareholders, because a person who might be in South Africa can become a shareholder of your DAO or your organization. Whereas if your corporate is structured or is created in Nigeria, it means that you have to use the Nigerian policies to sell shares to a person who is in Kenya, which sometimes becomes a problem. But if you move your decentralized, your organization to blockchain, then there is no restrictions, but still some of the policies will be used to govern the way people vote in your company. So there is tokens. On our next slide, tokens are different from ETH in Ethereum. In Ethereum protocol does not know anything about them. So if in that the Ethereum protocol does not know anything about them. So this is why I told you that there is a big difference between Bitcoin and Ethereum, and one of them is because smart contract learning Ethereum virtual machine. So if somehow it doesn't know about this, it learns independently, and that's why they are able to like upgrade the Ethereum protocol without affecting the smart contracts. So when they do they did the Ladan hard fork, or when they did the Constantinople hard fork, the smart contract were never affected, because you can imagine if all those smart contracts that are in the Ethereum blockchain, and then the Ethereum blockchain did a hard fork, telling the other companies that now you have to do an upgrade because we have done an upgrade to our system. So it learns independently. The Ethereum virtual machine learns the smart contract independently of the Ethereum protocol. So sending ETH is an intrinsic action of the Ethereum platform, but sending or even owning token is not. So the ETH balance of Ethereum account is handled at the protocol level, whereas the token balance of the Ethereum account is handled at the smart contract level. So the balances of the tokens are handled by the smart contract. They are handled by the smart contract, but the ETH balance is handled by the Ethereum protocol or at the Ethereum level. To show you that, uh, to show you that you have realized or you have noticed that for you, when you create a token or you create a token, the Ethereum balances are generally there. But for other tokens, you have to add the token so that the balances can be shown, because smart contract are dependent. Smart contract are dependent. That's why you have to add the tokens there. uh so the other point is that to create a new token on Ethereum, you must create a new smart contract. You must create a new smart contract. So once deployed, the smart contract handles everything, including ownership, transfer, and access light. So this is what I was talking about as this is what I was talking about, the functions there, the functions that I was explaining yesterday. So the functions that I was explaining yesterday, these are now what those functions are now what we will generally build on top of. We will build a function to transfer. We will build a function to handle ownership of coins, and that's why yesterday when I tried send uh, to send tokens to the smart contract we deployed, I was unable because there is no function which is allowing us to like store those ETH in that smart contract. So you can write your own smart contract to perform all the necessary action you any way you want. It is possible to wise it to follow any existing standard. So sometimes you don't have to follow. You can create a smart contract without following the existing standard. But if you want your smart contract to be used by different protocols or different or other developers to use your smart contract, then you have to create it in a way that it's standard. Yeah, but there is no if you feel like you want to light it in your own way and create your own standard, then there is no limitation. Yeah. Then the other question is, why do we pay ETH, or why don't oh no why don't we use ETH to pay for every transaction on the Ethereum network, saving the introduction of any token? So the answer to this is simple. Even in real life, there are tons of places where we use a form of token over cash, and will also confirm to this will also solidify the answer that Abros was asking about, why we have a lot of tokens. So even in real life, we also have we also use a kind of a form of token over cash. So the same way supermarkets do offer tokens, they offer rewards for you to redeem. If you normally shop at that particular supermarket, they offer you points. Those points, in general, are all actually they are just tokens. They are just like incentive so that you can be able to shop more there. So yeah, Ocean Park is like a DApp. your money is ETH, and the least band is the token. So is the token. So something like Disney World, for you to access maybe the amusement park, they normally give kids a wristband. So the wristband is the amusement park has their own form of tokens. They generally they that any person who wants to enter the amusement park uses. So and yeah, so for you to access the amusement park, the parents have the money, the cash. So they normally fund the wristbands with tokens, all points that the children go and redeem so that they can be able to access the amusement park. I've also seen in here in Kenya in the two livers mall, they do that for you to access the go-karts. You must have a card to access the the services. So by using token to execute certain function in the smart contract of the dApps, you make the process much more simple and seamless. If the demand of a dApp is sufficiently high, and with the supply remaining constant, the value of the token is going to be high. Yeah. So during those season, the points normally go high. Yeah. And this is what now makes the token or the tokens that have been created to be more variable. Yeah. Then we have seen the. I want us to finish up on this introduction to Ethereum. So you have seen we have talked about CryptoKitties, and what are CryptoKitties? CryptoKitties in blockchain is a blockchain-based game in which one can breed, correct, and hold kittens that are made and generated over Ethereum blockchain. These CryptoKitties are just like humans that are unique and cannot be replicated, taken away, or destroyed by anyone. So for those who used to liked to correct stamps, the post office used to create kind of unique stamps. People used to correct them, and then they were never replicated. So this is that kind of scenario being now taken to the blockchain using CryptoKitties. There's almost the same thing. So CryptoKitties are a new form of correctibles which one can trade, buy, sell, correct, like traditional correctibles. Yeah. The unique thing is that one can even breed this form of CryptoKitties. That is the best thing about it. And the result will be a totally unique new offspring. The ownership will be tracked and everything will be recorded securely on a transparent blockchain of Ethereum. So this is how the CryptoKitties system looks like, and then they offer it on sale. And then if you are a cat person, most people are dog like yeah. If you are a cat person and you like cats, you can buy and also do breeding. So what do you need to play CryptoKitties? So for you to do that, you just need a computer or a laptop running the desktop version of Chrome or Firefox. A MetaMask is a form of digital currency. So this by now, I hope everyone has MetaMask and MetaMask and Chrome, and this one is if you want to play, then you just you start praying. How do you start it? Then it can be bought from various resources. So you can buy it from various resources using credit card from Coinbase, Changerly, Bitpanda, and CoinMama and CA exchange and other decentralized exchanges. Once you have your ETH token, transfer some ETH to MetaMask wallet. So basically, these are exchanges, and yeah, for decentralized, you don't need to exchanges. You don't need to like transfer this ETH to MetaMask because they will be in your ETH wallet. So buying the crypto kitties, it is not a free game, so you are required to pay using it to actually play the game. You can start playing crypto kitties by buying or selling existing kitties, or else breeding with another to form a new and uniquely crypto kitty for yourself. In the MetaMask marketplace, you will see sale of crypto kitties going on. You can fund your MetaMask wallet and actually purchase one. So the link is here for CryptoKitties. You can visit and take a look at it and see how it looks like. So yeah, then we have and see how you can like interact with it, and yeah. So this is how you breed your CryptoKitties. And I'm not sure how much gas fee, even how much gas the gas fee for breeding CryptoKitties right now. But also, if you have Trust Wallet, you can on your Trust Wallet you can. So we normally have the wallet for those who have. Let me see if I can join meet. Oh no. For those who have Trust Wallet, on the top below the below the on the nav bar there is tokens and collectibles. So if you click on collectibles, you will all the collectibles that you own will appear there. But if down below the icons you have a wallet and dApps. So under dApps you can search CryptoKitties. You can search CryptoKitties. So Trust Wallet displays all the dApps that are created under the Ethereum blockchain. So you can click on dApps, and then on the navigation bar there is a search bar that you can type there and type CryptoKitties. And then we have decentralized exchange. In the decentralized exchange, you can actually swap using Uniswap. Yeah. So this is how you actually breed CryptoKitties. This is how you breed CryptoKitties, and then one can earn money playing. If one can earn money playing CryptoKitties. So CryptoKitties are not cryptocurrencies, but for a real world scenario, CryptoKitties are crypto collectibles. So cryptocurrency are like USD or Euro. Alas, or cryptocurrencies are like USD or Euro, whereas CryptoKitties or crypto collectibles are like unique stamps or a unique art that only you own. You can sell a crypto kitty in the marketplace at your desired price and earn a profit. The market price is driven by demand and supply of asking price. So people actually bid and create an asking price, and create what they can be able, they say what they can be able to pay. It is highly profitable if your kitties are unique and appealing enough to the buyer. Some crypto kitty was sold in the marketplace at a higher price at the time of Genesis, and also crypto kitties worth 4 million have been already sold. So it's the same to what happened to the biggest artist in America, like now, the digital artist who was able to sell his art for like, I don't know how many millions, but let me share. The most expensive NFT ever sold. So recently we had this 1 million, not that one, art, NFT art. So this one was from Kevin Abost. Uh, these are some of the most famous art and the most expensive art that have been ever been that has been ever sold. And yeah, they made a lot of millions. Made a lot of millions. Yeah, these ones made a lot of money. So this one actually belongs to Nifty. Nifty. Yeah. So those are some of the famous art that have ever been sold. Yeah. So CryptoKitties was created by Axiom Zen and spun out into a new company called Dapper Labs in February 2018, raising 12.85 million for leading investors, including Anderson. Uh, so those are some of the investors who invested there. Then we have initial coin offer. So I mentioned about initial coin offer, similar to that of is similar to IPO. IPO, that is initial public offer, and yeah. So these are the top coins again by market capitalization that has already gone to public, that they have been able to sell this coin to public, and this is their current market price. Then we have a graph showing token sales in different countries: Europe, North America, Asia, and yeah. So Ethereum development. So for Ethereum, in terms of Ethereum development, I think this one we talked about during the initial start of Ethereum. That is when it was launched, and up to now, almost up to 2021. So we have had major updates. So we had here in 2015 we had a node Frontier chain dead. We had Homestead, and then we had Ethereum Classic, which is still alive, but Homestead chain died. So Ethereum Classic is the Sprinter group. Then we had Homestead reset after the DAO fork. Then we had Byzantine. Old Byzantine chain will die hopefully. So this chain will die soon. Then we have Constantinople, and then we have Serenity, and then we had recently, by the end of 2020, we had the London fork. Yeah. So this is the plan and the four stages of the current four. Like I may say that they kind of are like they are five like now, five phases of Ethereum brand development. Yeah. So right from the early days, the core developers created an outline for a four-staged development plan for Ethereum. So we had the frontier, the early groundbreaking and testing of a platform that could support smart contract and decentralized application. You had the homestead, the formalization of how the Ethereum virtual machine works, and strengthening the ecosystem for smart contract development. So today, a friend of mine gave me a book to read called it's called Ethereum, Mastering Ethereum. It's written by Andreas M. Antonopoulos and Dr. Gavin Wood. So Gavin Wood played a major role in laying the foundation for the Ethereum virtual machine. So yeah, laying the work for how the Ethereum virtual machine will work and strengthening the ecosystem for smart contract developer and also the development of the Solidity language. So we have Metropolis. Metropolis solving the issues that came at scale during the scaling up of Ethereum, making Ethereum more amenable to large scale or performance of application and many uses. So Benzene time laying the foundation and Constantinople improving performance and setting timeline for Serenity. So Constantinople actually happened in 2019. Yeah, this major change. I was hoping that Constantinople was going to solve the issue of gases because in 2019 the gas actually were increasing. If yeah, the gases were increasing. So I was hoping that Constantinople would solve the problem, but never did at that particular time. So Serenity make Ethereum self-sustaining and high scalable with a move to proof of stake and shading state channels that allow for concurrent processing of smart contracts while still maintaining the serenity of the blockchain. So those are the staged development plan for Ethereum, and there are still more. So that's why I was also when I started the class, I said that one core component when you are investing in a project or in a coin, you must look at the long-term foundation, the long-term roadmap goals, and how the major milestone the project has been able to cover. And this is what makes Ethereum the second most powerful cryptocurrency because they have been able to cover major milestones and groundbreaking discoveries. Yeah. So Ethereum has gone through a number of planned and unplanned hard forks. So we had the Frontier, it was planned. Frontier Thoin was also planned. Homestead was planned. DAO fork was not planned because a DAO attack happened and then they had to do a hard fork so that they can be able to uh, maintain the security of the DAO. Then we had Tangerine. This one was not planned. The Dragon was not also planned, but Benzene time was planned. Constantinople was planned, and St. Petersburg was also planned. So, what is a fork? You have actually come across a fork on the road. A fork on the road basically means that the changes that have been made cannot actually be undone. Yeah. So we have a fork. A fork is a change in protocol causing the creation of an alternative chain or a temporal divergence into potential block path during mining. And then we have a hard fork. So we normally have a hard fork and a soft fork. So a hard fork is a permanent divergence in the blockchain, also known as a hard forking change. One commonly occurs when non-upgradable nodes cannot validate blocks created by upgraded nodes that follow newer consensus rule. So you have to like eliminate the ones which are not validating. Think of a hard fork as a major upgrade of an application, like a radical change in the application software, and a soft fork. It's just a simple change or an upgrade of like the way WhatsApp did. So they had a soft kind of a soft fork this week, whereby they have been able to like include features that are there in WhatsApp GB. Yeah, that's a soft hack, a soft fork, because it doesn't like really change the entire system or the functionality of the system. Yeah, so those are forks and hard forks and soft fork. Then we have the following Frontier and Homestead hard forks established a fundamental and stable application platform. So we have the purpose of the Frontier fork was to create a transparent and open release for developer to experiment and develop decentralized application. The first release of the Frontier had a hard-coded gas limit per block of 5,000 gas. Unlike the normal gas per block parameter, this special limit would not grow proportionally to the network usage. Then we have the Frontier Thawing, updated gas limit from 50K to 3 million gas per block. Then we had Homestead to stabilize the platform within the protocol and networking changes. These included the the EIP2, EIP7, and EIP8. So currently they have done the EIP 1559. Yeah. So the other three unplanned for hard forks were initiated in response to the DAO attack of 2016. Yeah, so they had to like change. So block 1,920,000 contained the execution of an irregular state change, which transferred 12 million ETH from the dark DAO and white hat DAO contracts into the withdrawal DAO recovery contract. The recovery contract returned the DAO token holders if under the control of a curator contract. The forking caused Ethereum and the Ethereum Classic to split into two competing systems. So this attack was actually started by the Ethereum guys. They had a disagreement, and yeah. So starting from 18 September in 2016, the Ethereum network was attacked by a person or group, resulting in larger delays before transactions were processed. The network was then filled with pending transaction, which was causing users delay in processing their transaction. It was essentially a denial of service, that is a DOS attack on the Ethereum blockchain. Every operation that an Ethereum contract performs on the network was given a price or gas fee using the add operation. It's less computational expensive than performing a complex operation such as hashing a number using a secure hash 256. The attacker performed a DOS attack by repeatedly calling certain operation code in their smart contracts that were computationally difficult for clients to process, but very cheap to add to the network. In order to prevent the attackers from continuing to flooding the network with low-priced contracts with high computational costs, the gas calculation for certain input and output heavy operation were raised. So this is why I was also saying that we do need these proposals. We do need to come up with new standards. We need to create a formal way to do this. Yeah, so this EIP 150 and EIP 158 is a proposal that was created to counter this DOS attack. Yeah. Then we have the Dragon. It is the second hard fork of the two-round hard fork response to the DOS attack on the Ethereum network in September and October 2016. The hard fork addressed important but less pressing matters such as further turning, OPC code, pricing to prevent future attacks on the network, enabling drawouts of the blockchain state, and adding pre-attack protection. So it also included these EIP proposals. And then we have the benzenite, and then we have the serenity phase, which will follow and bring the breakthrough to the mainstream. And this one is now the proof of work, from proof of work to proof of stake. So Serenity is the last phase that and has one key principle to switch the Ethereum network from proof of work to proof of stake, essentially reducing the power of consumption of the Ethereum network. So POW means miners are in competition for the block rewards, where they are proving the computers are calculating compute cycles. POS means the miners use invested ETH to simulate the actual mining process to compete for the block reward. So it's the other way. So people, it's like they are betting to actually do the mining so that they can get a higher reward, kind of. Then we have the risks that are there, and some of these risks have been mitigated and solved. So hash lessons are learned by developers and the users alike in discovering the nuances of the language and the EVM, the Ethereum virtual machine. So yeah, this one I actually I can relate to this one, the reentrancy problem. And it happened to the first contract that I created, and I had to go back to the drawing board and create a smart contract to prevent reentrancy. And this reentrancy was actually being uh, triggered by this one, because I remember I had to like come up with go to the developers group and ask the developers group on the forums how to like how to solve the overflow error. The overflow error is where coins are coins are created out of thin air without triggering any code. It was an arithmetic problem. So we have a contract that is called safe math. Safe math is the one that is used for this, this one. Safe math is the one safe math dot sol. So safe math is a contract used to help in calculation. And at that time, I never knew about Open Zeppelin contract. So it's a library. It's a library that has the function to add, to subtract, and multiply and divide. So you normally call it, if you want the tokens to be added or minted, you use the function add. So the safe math was kind of written had a bug. It had a bug that would trigger the contract. If you try to send like one UBN or one token, then the contract would regenerate other more tokens, like 10 billion of them, yet you have just sent one coin. Then on the sender's address, the sender would be having now 10 billion. This library had an error. Yeah, and then the entrancy, the contract that does that is reentrancy guard. So you can also visit OpenZeppelin and see the OpenZeppelin is a company that does smart contract audits, and they also have a standard way or templates that can be used to that you can use for your smart contracts. So we have different contracts here, as you can see. These are templates that you can use to follow. We have for access. This one is for controlling the access of your smart contract. This one is for finance. This one is for governance. These are interfaces. These are meta transactions. These are mocks, proxy, security and tokens, and utility. So we have another smart contracts that deals with reentrancy. That's where reentrancy. Uh, yeah, this is the smart contract that deals with reentrancy. So these contracts help to prevent reentrant calls. This is uh, to prevent multiple or other calls from other contracts without the permission. Yeah. So this one it's already you don't have to change anything, but you just have to include it when you are creating your token. So any calls to non-reentrant after this point will fail. And yeah, it basically helps you to protect your smart contract from reentrancy. Yeah, that is reentrancy. Then we have an accepted ETH. We have a delegated call. We have default visibility, and we have entropy illusion. We have external contract referencing. We have a short address, stroke parameter attack, and we have then we have seen about denial of service. We have seen floating points. Some of these are the list all security loopholes. Basically, some of them occurs on the like the DOS denial of service happened to the blockchain, the Ethereum protocol itself. But for the other ones like reentrancy and arithmetic overflow and unaccepted either some of them happens on the smart contracts. And yeah, so I think this one we can do on Monday so that we can do the verification of contract, if that's okay. Yeah. Hello.
It's okay.
Yeah,
Yeah, we
so that
can.
we
Yeah,
can
it's okay.
yeah, so that we can finish up on the tutorial that I started, so that we can verify the contract, and then we can do the DAO attack on Monday. Yeah. Cool. Yeah, so that yeah, because it's a lot. It's a lot because you can see there is code, there is yeah, and then we will be
Okay.
we will actually be through. Yeah, we will be through. Yeah, so let's do the verification of the contract that we were doing yesterday. So if you remember, we deployed a contract yesterday, and this is the contract address. This is the contract address on the either scan or in the link bay testnet. So for you to verify the code that we have deployed, you just click on the verify and publish your code. So remember to select the compiler that we had. So when you are selecting the compiler, if you want to verify your code, you basically select if you used a single file. So for us, we used a single file. You see, we only have one file, this file called hellocontract.sol. If you have a lot of files, like what will happen when we start creating the ERC20 token, you will now select a different compiler, like multiple path files, all Solidity, standard JSON, all Viper, experimental. But for us, we used a Solidity single file. And then you select the compiler version. So the compiler version always start with the lowest. So we used 0.6. We used 0.6.0. So we'll go to 0.60. That is our compiler version, this one. And then we will select the open source license we have. So we used this license. These are named MIT license. I think this one is MIT license 3.0. So we will select it from here. MIT, yeah, there, MIT number 3. That is MIT. Then we continue. And then once we continue, remember the on our side on our sidebar from the Solidity compiler, we had selected autocompiler, and then we had enabled optimization. So we had enabled optimization. So here we will still select optimization. We will say yes, it was optimized, and then we will come and copy our code, this contract, this one. We'll copy it like that and then paste it here. So once we have pasted it there, we don't have a constructor argument ABI. We don't have other things. So what we'll do, we'll just select and say we are not a robot, and then verify, and then wait for the either scan to or link back to validate the code. So found the following contract name in the source code, but we were unable to locate. So we have compiler warning. So the source file does not specify required compiler version. Consider using Pragma. Okay, so I'll just use I'll start over again. Sometimes the compiler gives yeah, didn't copy the same way it is here. So if you miss something up here, you have to copy the entire code. Yeah, this should work now. Yeah. Oh. We have a problem. But once we compile, it should look like this. Once you validate the transaction, or not the transaction, but your code, once you verify your code, it should look like this now. No, this one is not validated. So once you have validated your code, it should look like this. So the compiler version that was used at that particular time, and then we have other settings like default EVM version, and then optimization was enabled with 200 lands, and then the contract name. And then your contract code should be below there, and then we have these now functions will be available. The functions that were here, these ones, these functions here, this function name should be now available like this. It should be available like this. So if you want to transfer from this address to this address and the value, and then you can light, So to light, you have to connect to Web3 using MetaMask or this other wallet. And then now you can be able to light to like trigger a transaction. So for contracts, to know whether a company or a project is actually serious, you can actually tell. You can actually go, and if you're a developer and you want to know if those guys are serious about a particular project, you can do that. So we have had people who have deployed coins like this coin. Mm, this coin, actually. This, there was this other one. Yeah, this one. There was this other one. Don't know whether they verified their contract. So you just go here at this tab, contract. Yeah, they verified. They verified the contract. They verified the contract. Yeah, they verified the contract. I thought they hadn't verified. Yeah. So this is how you somehow you look for projects that have been, if they haven't verified their code. Let's see even Uniswap. Swap. These are some of the things that you normally look in a project. We have the contract. Yeah, so these guys are also verified, and this is Uniswap. So this one is for minter. This one is for minting. This is the address that will be used to mint other Uniswaps. To mint other unis. Then we have the function to do that. We have the function to do that. Yeah, so that's how you take a look at you look at the project which has been whether the project is serious or whether they have serious developers on board. Yeah. So there were some coins back in 2018 that were not verified. They never verified their code, and yet they were selling coins. They were selling coins. They were telling people that we are selling this, we are doing this. That is if the code is not verified on etherscan.io, then it means that these guys are not serious, and these guys will end up scamming people or something. Yeah. Then
Question.
there are others who can create.
Hello?
Yes, hello.
Yeah, but like for this that we are trying to verify the contract, is because we are using a Ethereum blockchain.
Yeah, yeah.
Supposing those other guys they didn't use an Ethereum blockchain, will we be able to see verify
If they
their
never used
token?
the Ethereum blockchain, so we will be kind of looking at Zero and Ethereum because so Zero has alpha, alpha Zero, Brock Scout, I think Scout, Zero Brock Scout. See, let's see. Yeah, so this is the Zero Explorer. It has the same it has a different UI. They have a different UI. They have a different UI, but it's the same. It serves as the same as etherscan.io. So you can see the tokens which are listed on the Zero blockchain, and then no. So you can see the native coin, you can see the $0, and then you can see the Mula CUSD, and then Zero Doge. So we can actually look at the Zero Doge. So Zero Doge, and then you can read the contract. You can read the contract. Let's see. It's the same way. It's the same way. It's just a different user interface. The same for Polkadot. Polkadot. I don't know Polka Polka Polkadot Explorer. Polkadot Explorer. So it's taking time to kind of load, but it's the same thing as Etherscan. The interface is the same. It's the same. So you can see the holders here on the Zero Block Scout. The token holders are there, and the transfers and addresses are there, and the decimal places of the contract. So you can see the list of the holder, and it's also an ERC20 token on the Zero blockchain. So Polkadot Explorer is Poker Scan. So from Poker Scan, you can also see I've never interacted with Polkadot network that much. So I think I think this one is the main block. So I've never actually interacted with Polkadot. This is the first time I'm opening it. Uh, So it's the same thing. If you want to see if a project is serious, you must have a good website. They must have a good developers team and a good community based, yeah, and a good community based. Yeah. So this is Polkadot. I've never actually interacted. So this one is a bit new. Yeah. So, or if you want to, different blockchain have different user interface called user UI or different dashboard. Yeah. Mhm. I don't even know the coins which are listed on Polkadot or projects which are listed on Polkadot. Yeah, but I'll do a research on this and on Polkadot and see. Yeah, but the Explorer is the same. The Explorer is the same. This one, the Explorer is the same as that of Ethereum and that of Zero. Yeah. So on Zero, sometimes this new blockchain, yeah, this some if you want to lead, actually you don't. If you are building on Zero, sometimes you don't even need to like verify your contract here. If you're building on Zero, you don't need to go through this process or this process to verify. And when it comes to local development, you also don't need to do this. You just push you just push your code, and then the contract will actually be verified. The code will actually be verified. So on Zero network, it's the same. So you can query the number of amount. You can see the total supply. You can see the Uniswap V2 pair and the Uniswap V2 router. So this Dogecoin means that they have actually used, they have actually connected to Uniswap. You can actually go to Uniswap and transfer these coins. So this is read and together with write. So this is read together with write. Yeah, so if you click on the transaction fee in form of AE, you can see the transaction will actually load in AE, and if maximum amount liquidity in AE, you can see. So that's how you kind of like interact with the Ethereum Explorer and different explorers. Yeah, yeah. The same case for block Bitcoin. Yeah, this one is the Bitcoin Explorer. From like this one is the Bitcoin Explorer. Yeah. So there yeah, you can do Bitcoin Cash, you can do Ethereum Explorer, and then the Bitcoin Explorer. There are many explorers. There are many explorers where you can be able to see the blockchain themselves. Yeah. But for all of that, think of the explorers as like the NS, not the NSC, like the correction of the entire company, the correction of the entire company, how you can see other companies or other departments listed on that on that company, all departments in that company. How can you explore and see the department of USDT, like something like that? Yeah. So yeah. So if anyone has a question, this will be the right moment to do so. Yeah, yeah. If we don't have a question, then I'll ask a question.
Hello, one question.
Yes.
Hello.
Hello.
Okay, right now. Hello, can you hear me?
Yes, yes, I can hear you.
Supposing one is developing a smart contract, but it's not based on currency. Do you should go ahead to verify the smart contract the way you are trying to verify the token on the Ethereum network?
Yeah, yeah, yeah. It will be the same way. It will be the same way when if you are developing a different smart contract, it's the same way you will be doing. It's the same way. Yeah. You will be using the same process to validate, to the same process to deploy, the same process to verify. But now when it comes to complex development, you will just need a local, instead of using remits, you will need now to download the tools like Ganache. You'll need to download Ganache. You will need to like download Truffle. You will need to install Node.js. You will need to install the, npm package manager, Node package manager. Yeah, and then for that is for local development. You will need all that to do that development, because now it becomes expensive for you to use limits, because you must be in the internet to do all the testing, to do all the debugging. You have to be connected to the internet. But if you have the local environment or local network, uh, if you are using the local network, then the development of a smart contract becomes easy. Even deployment, you don't need to like deploy it from here, because you want it to. If you see, if we are deploying it from here, you see, we are not creating the UI part. We're not creating the UI part. So creating the UI part, it means that now you will have to go to this site and then download the contract ABIs, download the contract ABIs, and then use them to now start creating the UI, of which it will be tedious. Let me show you the application that I was building, and you can see the file structure. So the file structure, when it comes to local development, you have the source. The source is the source. This is now the React or the UI. These are the UI components, or the files, everything and everything. So the contract APIs, when you deploy or you compile your contract, comes here. They are stored together with the source, together with the files that comes with the contract. Then if you go inside the contract folder, you will see now the .sol, .sol, the contracts themselves. And then now the UI is these other parts. These other parts. So these are the action, the reducers that will create the interface of the web application, the decentralized web. So this one I was trying to create a decentralized exchange. And when you are creating an exchange, you still need to create your own coin. So this is a simple coin, that I had created with simple functions and everything. And yeah, so this is the function for transfer. This one is for approve. So you need to approve that particular address so that it can be able, and the amount of value the sender or the user wants to spend on when you are in that particular exchange. Yeah. Then there is internal. These are internal functions. These are normally used in the inside the contract. They are not from outside. They are not from outside. So this one is public. This one is public, and this one is internal. The internal has been actually replaced. Private has been replaced with internal. So this one are public. They can be used by other contract, and they can also be used. They can also be viewed by the public. Yeah, and yeah. So anybody can access this function. anybody can trigger this function. And then we have now the constructor that holds the total supply and the balance of that particular sender. So this is what I was telling you about, that the contract is responsible for holding balances of addresses. So we have this one. This one is for mapping all the addresses that will be in that particular smart contract. And this one will be mapping the balances of all, not the balance of all. This one will be mapping the allowances, the allowances, sorry. This one will be mapping the balances of all the holders, and this one will be mapping the allowance of all the addresses. And then this one it will be an event, it will emit an event for transfer, and then it will also emit an event for approval, so that the tokens can be exchanged in an exchange. Yeah, that's why you have to have this protocol. This is actually the simple, the standard, the standard, a coin that has the ERC20 standard. Yeah. So for this, that is the backend. So generally, how the the structure of the normal application, web application, the way it is structured, we have the backend, which connects to the database, and then we have the front end, which connects to the to the to the backend. So for smart contracts, smart contracts are the backend, and the UI is the any framework that you would want to use. So you need to have an advanced setup on an advanced configuration of your system, so that you are able to do that. Yeah, but slowly by slowly, we will be able to now see how we can be able to consume those functions for front end use. Yeah, so this one is a basic. This one is not that one, but so this one. So this one so this one for limits, this one is a simple way, or an easy way to actually debug if you are not used to debugging from the console. So you can debug using this one, because this one is user friendly for when you are starting. And it doesn't mean that you cannot create complex smart contracts using limits. You can. You can create complex. The Ubricoin ERC20 token, I started creating the coin using these limits, and then I started with one folder, and not one folder but one file. But later on, I came adding other files and folders, other files, and yeah, other files, and like the reentrancy file, or the reentrancy guard file was not there, so I had to like source it from OpenZeppelin, and then yeah. So yeah, that I hope that one is clear.
Okay.
Yeah.
It's okay.
Yeah. So yeah, that is it about Ethereum. So on Monday we'll complete on the DAO attack, and then I'll introduce on that was lesson 3. So I'll introduce lesson 4, lesson 4, lesson 4, and this introduction to blockchain ADS final PPT or slides There is assignments that I've written, there are assignment that I've provided, so you can attempt them. So we have the benefit and limitation of Ethereum, the difference between mainnet and link bay and private network. Yeah, can attempt them. Yeah. So on next week, I will introduce cryptography and wallets. So this one is not that big. This one is not that big. You will know the differences, different wallets and different cryptographic methods used in blockchain. Yeah. So I hope you have enjoyed the lesson, and I hope you have also learned a lot. And yeah,
Yeah.
so any comment, anything? Yeah. Yeah. So have a great weekend, and I'll share the I'll upload the videos, and then I'll share the link and the this other PDF that has the DAO attack. I'll share this one also under the same folder, the folder, the same folder. Yeah.
Yeah, thanks.
Okay.
Yeah,
Have a,
it's okay. No
okay.
comment. It's okay.
Okay. Uh,
Yeah.
Damaris, do you have a comment or suggestion or something?
I'm fine.
Okay. Okay. Yeah. So have a nice weekend and a lovely evening. Bye.
Yeah, bye. Same to you too.